We are going through exercise 16D. In this video, I'm going through question 2B. So we've already read out the question 2. So let's just go straight to B now, where it's asking us to estimate the instantaneous rate of change of cardiac output with respect to workload at the point where the workload is 450. So let us come here. And remember, when it's asking for instantaneous rate of change, it's really asking us to consider what the tangent is going to be at 450. So if I was to draw that, 450, let me actually draw that first. 450 is going to be about here, is it not? It is. So if I was to draw a tangent at that point, it's going to look something like this. There, something like that. That's what it's going to be. But as we know, we can't find what the gradient is going to be at that point because we only have one point. So what we're going to do instead is we're going to draw a secant. And we're just going to choose 2 points that is going to approximate this line right here. And what we're going to do, let's go through, let me just move that for the time being. Let's go through this point. And the reason why I'm choosing it is because it nicely lines up. I can clearly read that that's going to be 615. And then the other one I'm going to do is right here, which is going to be 0 and 5. So hopefully you can see why I've chosen these points, because when I draw a line through them, it's very, very similar to the tangent that I drew when I went through 450. So I'm going to use these points right here in order to approximate my instantaneous rate of change. So that means, again, what I'll be doing is finding my rise over run, my rise over the run. What is my rise going to be? It's going to be this distance right here. So it's going to be between 15 and 5. So to get that, I'm just going to go 15 minus 5. And my units here are liters per minute. And then to find what my run is going to be, it's going to be from this distance to this distance, which is going to be 600 to 0. So it's just going to be 600 minus 0. Now that's going to be kilograms meters per minute. Kilograms meters minute. I don't have to consider my minutes because they're both on top and bottom. Then I'm just going to do some simple maths. 15 minus 5 is 10. 600 minus 0 is 600. Having done that now, what I'm going to do is make sure I still write my units here. So it's liters, kilogram, minute. I'm going to grab out my trusty calculator here and go 10 divided by 600 is going to be 0.01666666. So it's going to be 0.0167. Let's do that. And my units is going to be liters per kilograms a minute. Kilograms a meter. And that is going to be my final answer. So hopefully you were able to attain that. That is what the back of the book has. Perfect. So, whoa, look at this. This happens. My OneNote is freaking out, but I've come to the end of the video. That is my answer. I'm going to stop here and not move anything because hopefully we'll finish the question. Let's just take note of how funny OneNote is. Ready? Whoa. OneNote, you're crazy. Okay. Hopefully that made sense to you and you were able to answer it. Instantaneous rate of change, very important.